So now that we have seen representing the irrational numbers root 2, root 3, etc. on the number line, let's try to see if any real number can be represented on the number line in approximation exactly where it has to be located. So here my session is about representing real numbers on the number line. For example, I take the number x equals 2.6. Now it is very easy to locate the number x equal 2.6, or say for example I take x equals 3.7. I find 3.7 to be easily located on the number line, because if I have the number line with minus infinity, plus infinity, 0, 1, 2, 3 and 4, etc., then I find 3.7 approximately here. So how do we get this to be approximately on the right side is how we're going to discuss in the number line. So this representation of 3.7 is just because if I take a second number line which is extended which is zoomed out for between 3 and 4, I see that between 3 and 4 I have 10 different scales: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So I get this to be 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.9. So between 3 and 4, I again subdivide the scale into 10 units, breaking up at each unit being 3.1, 3.2, 3.3, 4, 5, 6, 7, 8, 9 and 10. Is how I get this point, exactly the 3.7, which is located by using the second number line out here. So my 3.7 is located through subdividing the scale between 3 and 4 units into re-subdividing again into 10 different units, so that I can exactly locate 3.7 on the number line. Say I continue this with the number x1, which is 3.74. I would like to locate the number 3.74, which is again more approximate value than 3.7. So what do I do with this number line? I start with the first number line between 3 and 4 somewhere out here. Again I subdivide. I get between 3 and 4 10 different units, and again 3.74 lies between 3.73 and 3.75. The value on the left of 3.74 is 3.73 and the value on the right of 3.74 is 3.75. So what do? I pick between, and also this value is between 3.7 and 3.8. So this value of 3.74 lies in the region between 3.7 and 3.8. So this is the region where this value lies. Therefore, I try to again break up this interval into 10 subdivided intervals. Now let's see how the number 3.74 up to 2 decimal places be represented on the number line exactly through its subdivided interval. Now as we know that 3.74 lies between 3.7 and 3.8 in this interval of, we'll try to make a number line between 3.7 and 3.8 subdivided again into 10 different intervals. So we get this to be minus infinity to plus infinity of, I take 3.7 and 3.8 and I subdivide this into 10 different intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I get this to be 3.71, 3.72, 3.73, 3.74, 3.75, 76, 77, 78, 79, and this is finally 3.8. So my 3.74 can clearly be identified to be out here, which is 3.74. Is how we understand the subdividing of intervals through which we can reduce or zoom in and zoom out the real number line accordingly as the number of decimals increase or decrease. For example, I continue further with the new number x2, which is 3.742. Then I have my third decimal, which is 2, and I clearly have this number lying between 3.74 and 3.75. So I try to locate the region between 3.74 and 3.75, and I make a new number line breaking up with this, and I have my 3.74 divided into different subintervals 1, 2, 3, 4, 5, 6, 7, 8, 9, and then finally I get to be with 10th interval, which is 3.75. Now 3.741 lies here and 3.742 lies here. 743, 745, 746, 747, 748, 749, and 3.75 is what we get out here. Therefore, the number 3.742 is said to be exactly lying out here. So here is what I identify, and proceeding similarly, as the number of decimals increase, the number of number lines get zoomed in and zoomed out, and where again the subdivided intervals can make me locate exactly the number fixed located on the real number line. Therefore, finally, the learning outcome is that every real number can be represented on the number line, however big the number of decimals are. The successive magnification of the given decimals through the successive magnification of the number line will finally give us, through the first magnification, which gives me the value 3.7, the second magnification, which gives me the value 3.74, and my third magnification, which gives me the value 3.742, is how I identify that through different successive magnifications I can visualize and locate the given decimal values on the real number line. Successive magnification is possible for identifying the real numbers on the number line.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.